Hello, 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 and welcome back to Shiksha DaCosta. Today we're going to look at equations of circles. Today we're going to figure out what is the relationship between x and y that in such a way that when we graph it, it's going to actually create a perfect circle where the center is at the origin. To start us off, I'd like you to do a little research project here. A Pythagorean triple is a set of three numbers, three positive integers, and in such a way that those three can be assigned to the side lengths of a right triangle. And the most famous of those is this one, 3, 4, and 5. And this, you can assign the numbers 3, 4, and 5 to the side lengths of a right triangle like so, or maybe even 4 could go here, 3 could go here, and 5 would be the hypotenuse. Um, what I'd like you to do right now is using the internet. So pause the video here and see if you can find at least 4 other sets of Pythagorean triples. Well, hopefully you were able to find a few. I'm going to bring some up here so you can compare that against your own notes. The next one I found besides 3, 4, and 5 is 5, 12, and 13. 5 squared plus 12 squared equals 13 squared exactly. Going a little bit bigger, you might have found 8, 15, and 17, or even 7, 24, and 25. Now we could keep going to find more and more Pythagorean triples. But one thing we can do to sort of find a fifth or even a sixth or seventh one pretty easily is just find a triangle that's similar to any of these, which means the side lengths are all the same side lengths multiplied by some constant number. Pause the video here and see if you can figure out another triangle without looking it up, another Pythagorean triple. Well, one thing I did was I took my basic triangle here and I said, let's multiply all the side lengths by, let's say, 5. That would create a triangle that's 15 by 20 with a hypotenuse of 25. All three of these are just these side lengths times 5. So one thing to take away from here is if ABC is a Pythagorean triple, these are three numbers that could be the side lengths, like 3, 4, 5, then KA, KB, and KC are also going to be a Pythagorean triple where K is any positive integer. I could even make a triangle like this. I could take the side lengths and multiply some of them by -1. Notice I took this and I made it this side length instead. I took this and I made it this side length. I can even make them negative. And when I try to find, the length of the hypotenuse, -5 squared is going to give me the same length as 5 squared. And -12 squared is going to give me the same length as 12 squared. And so when I add those together and I square root it, I will still get 13. This is technically not a Pythagorean triplet because a Pythagorean triplet has to be three positive integers. But I bring this example up just because you can see that if you have a Pythagorean triplet, you can make a similar or congruent right triangle just by taking the side lengths, any of the side lengths, and making them negative. And that because we have to square that to get the hypotenuse, that actually won't change too much about your situation at all. That won't change the length of the hypotenuse. You can even swap the sides or move the triangle or flip it to a different orientation as long as the absolute value of the legs have the same pair as this one. The hypotenuse will remain unchanged. In this investigation, I'd like you to explore the following. When planning the introduction to a boss fight in his latest video game, Sven wants the game to pause and play a video the moment a player moves to within 25 feet of a dragon's egg. What coordinates could the player be at in order to trigger this cutscene? Pause the video here and see if you can find at least 12 sets of coordinates that would trigger the video, the cutscene, to play. Well, I'm going to start off with some of the easiest coordinates you can find. If you have to be within 25 feet, then the coordinates 0 or 25, 0, or 0, 25, or even 0, -25, or -25 and 0, those are all exactly 25 feet away. Another way we could get 25 is by creating a right triangle with side lengths of 15 and 20, right? 15 squared plus 20 squared would give us 25 squared, and that is one of the Pythagorean triples that I just looked at. Right, 15, 20, and 25 was that Pythagorean triple that I made by scaling up the most basic Pythagorean triple. I could also, like I mentioned, swap the x and y coordinates, right? And now instead of being 3 or 15 by 20, it's 20 by 15. But the hypotenuse is still 25. And yet another Pythagorean triple that I found that has a hypotenuse of 25 is 7 and 24. So a side lengths of 7 and 24, 7 squared plus 24 squared does give us 25 squared. And just like these two, I can also flip the x and y coordinates or make them negative, and I can find 4 more coordinates. So take a look at these could all be points where if the player's coordinates are exactly that, the dragon's egg will hatch and the video will play. What do you notice about all of these points? Well, hopefully you noticed the same thing as I did. These are all in a circle. These form a perfect circle around the dragon's egg with a radius of 25. And all of these, like we mentioned, all satisfy the equation x squared plus y squared equals the hypotenuse squared. And in this case, we can see that the hypotenuse is the radius of that circle. So we're actually going to label that r. And to break this down further with the examples that we used, for example, I could have taken 25 squared plus 0 squared, and that gives us 25 squared, obviously. But even negative 25 squared would give us the same thing because we are squaring it. So whether it's positive or negative, the answer for when we square it will be positive, or the value when we square it. I could have also swapped these places because these are being added, so the order of addition doesn't really matter. It's commutative. So even 0 squared plus 25 squared, or 0 squared plus negative 25 squared, those still give you 25 squared. For our blue points here, we can see that positive or negative 24 squared plus positive or negative 7 squared, or the other way around, still gives us 25 squared. And so does positive or negative 4 squared plus positive or negative 3 squared. All of these give us the radius of 25. So in this investigation, we saw that the equation of a circle that with the center at the origin is x squared plus y squared equals r squared, where r is the radius of that circle. If you want to sketch that graph out, it's actually really, really easy. All you have to do is plot one thing that I would recommend at least, is to plot the endpoints on the axes. So 0r, r0, 0 negative r, and negative r0. And then connect all of those with a nice smooth curve, just like so. And just like that, you will have created a circle whose equation can be described by x squared plus y squared equals r squared, where r is the radius. Do you think you could find the equation of a circle with the center at 0, 0 and a radius of 41? Pause the video here and see if you can figure that out for yourself. Well, one thing I know is the equation of a circle is x squared plus y squared equals r squared. So if r is 41, then r squared would be 41 times 41, which is 1,681. And so the equation of that circle would just be x squared plus y squared equals 1,681. Can you determine the radius of a circle that's defined by this equation, and then can you sketch its graph? Pause the video here for as long as you need and go ahead and do that. Well, first, I'm going to find the radius of the circle. So if this is x squared plus y squared equals r squared, so if 225 is r squared, then I can square root it to find out that r should be 15, because 15 times 15 does get us 225. And that tells me that the radius of the circle is 15 units. So I'll pull up my Cartesian coordinate grid and I'll plot some points, one here at 15, 0, 0, 15, 0, negative 15, and negative 15, 0. And then I'll just connect all of these with a nice smooth curve, just like that. A curve that follows this radius of exactly 15. Can you find the area of the yellow portion of this figure to the nearest tenth? Pause the video here and see if you can use those analytical geometry skills to do just that. Okay, so if you were like me, you started off just by stating just the basic facts. The area of the yellow portion is probably found by taking the area of this circle and subtracting the area of triangle ABC. And the area of a circle is always found by pi r squared. The area of a triangle is always base times height divided by 2. So here are three variables I need to find out. The radius of the circle, that will allow me to find its area, the base and the height of this triangle. Now the radius of the circle, very clearly, I could say it's the distance from the center, the origin, to any point. And I can say in this case, I'll say point A. So from O to A, that distance right there, that's the radius of the circle. And I can just use my length of a line segment formula, right? 8 squared plus 15 squared gives me the radius is exactly 17 units. And that's the same thing as the length from O to B or O to C. All three of these points are on the circumference of the circle. And so they will all, the distance between them and the origin should all be the same, the radius. Now, for the triangle to find its base, let's say that the base is this side right here, because I noticed that this side is actually horizontal, perfectly horizontal. The y coordinates of the points are both 8. And so I could just sort of, without even doing any calculations, I can see that, okay, this distance here must be 15, and this distance here must be 15 as well, or negative 15. And so the total distance would be 30. And I can confirm that just with the length of a line segment formula here, right? 15 minus negative 15 squared plus 8 minus 8 squared, that'll be 0, gives me the total length of the line segment is exactly 30. So that's the base. Now for the height, that's a little bit trickier, right? The height would sort of be like this distance right here. And I need another point here to describe that. So this would be the distance BD, which meets the side length AC at a perfect right angle. How do I find the length of BD? Well, actually, the y coordinate of D is actually already 8. I can see that. And the y coordinate here is negative 17. So the distance between those is just the difference there. 8 minus negative 17 is 25. And so this distance right here, the height is 25, the base is 30, and the radius is 17. So to find the area, I'm going to go right back to this formula. I'm going to plug in my values that I now know, the radius, the base, and the height. And I'm going to start to evaluate. 17 squared is 289. 30 times 25 divided by 2 is 375. And when I put this into my calculator, I'll get about 532.92. I'm going to round that to the nearest tenth. So the yellow portion should have an area of about 532.9 square units. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.